sometimes if we look at solving proportions using the cross product, we can cross multiply. Product means to multiply. We can cross multiply, not cross cancel. Here, we are trying to cross multiply. We would say A times D, AD, equals B times C, BC. We like to use the cross products when we can't use logic to solve proportions. If I look at this problem, I do see that 4 evenly jumps up to 8. So I could still use my technique of 4 times 2 is 8. Therefore, 3 times 2 is 6. X would equal 6. Whenever it's possible, I would use that technique. But what happens on the next problem when we see 12 going to 8? It doesn't have an even jump. 12 divided by any number is not going to give me 8. This is when I would want to use the cross products. We're going to cross multiply. 12 times x equals 12x. Put them next to each other to show that multiplication. Equals 21 times 8. (21 times 8 is 168. What we've created here is a one-step equation. What's being done to x? It's being multiplied by 12, and so I'm going to divide by 12. Whatever I do to one side of the equation, I need to make sure I'm doing the same thing to the other side of the equation to keep it balanced, to keep it equal. 12 divided by 12 cancels to 1x. And then I need to figure out 168 divided by 12. 168 is being divided by 12. 12 doesn't go into 1. 12 into 16 one time. 1 times 12 is 12. I subtract. Bring down my 8. And 12 into 48 would be 4 times. 4 times 12 is 48. No remainder. Our answer is 14. 168 divided by 12 is 14. Therefore, x equals 14. Again, there is no even jump between 10 and 25, so I'm going to use my cross multiplying. X times 25 is 25x equals 10 times 30 is going to be a 3 with 2 zeros, 300. Divide by 25 because x is being multiplied by 25, and whatever I do to one side of the equation, I've got to do the same thing to both sides of the equation. Canceling, and we get x equals 300 divided by 25. How many quarters are in $3? There's 4 quarters in $1, 8 quarters in $2, 12 quarters in $3. Let's just check our math and do 25 into 300, or 300 divided by 25. We see that 25 goes into 30 once. And when we subtract, 30 minus 25 is 5. Bring down my 0, and 25 into 50 goes twice. So 300 divided by 25 is 12. On this part, you may use a calculator. Driving, we are trying to use proportions to solve the problem. Lori drove 232 miles in 5 hours. There's a ratio. 232 miles in 5 hours. At this rate, how long will it take her to drive 580 miles? Where am I going to put 580 miles in this proportion? Am I going to put it in the numerator or denominator? This says that miles is in the numerator and hours is in the denominator. Therefore, I need to put miles in the numerator if I'm creating equivalent fractions. The question asks, how long will it take? And that will be my x. X stands for time. We're going to do the same thing that we just did. We're going to cross multiply. 5 times 580, we get 2,900. And 232 times x is 232x. X is being multiplied by 232, so I'm going to divide by 232 to both sides of the equation, show my canceling, and we get that 2,900 divided by 232 equals 12.5. It would take 12 and a half hours to travel 580 miles. Indirect measurement. The properties of similar triangles can be used to find measurements that are difficult to measure directly. This is called indirect measurement. One type of indirect measurement is shadow reckoning. The diagram at the right shows how two objects and their shadow form two sides of similar triangles. You can use this proportion to find measurements such as the height of the flagpole. So the same way that we did when we had similar figures before, we could say that the left-hand side of the triangle, so we could say, we'll call this x. We could say x is to 4 as the bottom shadow is to the bottom shadow. 24 feet to 8 feet. Here I see that I have a shortcut. I could do 8 divided by 2 is 4, so 24 divided by 2 would be 12. The height of the flagpole would be 12 feet. One more. A school building cast a 40.5-foot shadow. At the same time, a 5.8-foot student casts a 4.4-foot shadow. How tall is the school building? So here's our ratio. We have 5.8 foot is the student, and the student casts a 4.4-foot shadow. All we know for the next piece is that we have a shadow, and the shadow is in the denominator. So the school building has a 40.5-foot shadow. And it's asking how tall the building is. Again, you're going to cross multiply and solve. 4.4 times x is 4.4x. Using our calculator, we have 40.5 times 5.8, 234.9, and then x is being multiplied by 4.4, so we're going to divide by 4.4, and we get 53.4 feet, and that is the building height. Building height is 53.4 feet.